Hey y'all, today I'm going to be talking about solving quadratic equations. So we've already learned how to factor quadratic equations, but factoring quadratic equations is really the first step to then be able to solve those quadratic equations. So we're going to focus, and it's really just one little extra thing. It doesn't take a lot of extra work. We've already talked about how to find roots and zeros by graphing a quadratic equation, but now we're going to be able to find our roots, our zeros, our x-intercepts by factoring the equation instead of always having to graph it. So let's look at number one. So we have f of x is equal to x squared minus 4x minus 5. Of course, as always, y'all, we check for our GCF first. We have 1, 4, and 5 because 1 is one of our numbers. We can't take any other number larger than 1 out, and then everything does not have an x term in it, so we can't take any x's out. So no GCF, so we get to skip step 1. So we move on to step 2. Go ahead and drawing our box. Remember that before we start filling our box, we do multiply c times a, which remember it is ax squared plus bx plus c. So a and c is our first and our last coefficient. So in this case, it is 1 and negative 5. So 1 times negative 5 is equal to negative 5. Then, of course, we stick our b term on the other side, which is negative 4. Okay. So we need numbers that multiply to make negative 5 and add to make negative 4. So the good news, 5 is prime, so there's only one set of factors, which is 1 and 5. But we do, of course, need to list both because our a times c is negative. So 1 and negative 5 and negative 1 and 5. Then, of course, we are going to add both of those set of factors. So 1 minus 5 is negative 4, which is what we're looking for. So I'm not even going to worry about the other one. And then we stick everything on the outside. So x minus 1 and x plus 5. X times x is x squared. Negative 1 times x is negative x. X times 5 is 5x. Negative 1 and 5 is negative 5. X squared is x squared, negative x and 5x is, I picked the wrong one. This one. Sorry, y'all, ignore my previous statements. X times x is x squared, 1 times x is x, x times negative 5 is negative 5x, and 1 times negative 5 is negative 5. X squared is 1x squared. X and negative 5x does make negative 4x, and negative 5 is negative 5. So our factored form without our GCF in front is f of x is equal to x plus 1 and x minus 5. Okay, so now we're going to follow up on the other side. I want to find the root. So I have the factored form, but now I want to find the root. So we've already factored this. F of x is equal to x plus 1 and x minus 5. Okay, to find my roots, which remember roots are the same as zeros, x-intercept, solutions. So really I'm finding my solutions. I'm going to actually take this function, I'm going to set it equal to 0. Because our roots or our x-intercepts occur when y is equal to 0. So x-intercepts, y equals 0. And remember, f of x is the same thing as y. So if x-intercepts occur when y is equal to 0, then I can set my factored form equal to 0 to find when my x-intercepts are. Now here, note how with x plus 1 and x minus 5, those things are both being multiplied. I can actually take them and separately set each one to 0. So x plus 1 is equal to 0. And x minus 5 is equal to 0. So now that I've set each one separately equal to 0, I can then solve both of those factors, both of these new equations for x. So 0 is equal to x plus 1. What do I need to do? Minus 1 minus 1. And we get x is equal to negative 1. 0 is equal to x minus 5 plus 5 plus 5. And we get x is equal to 5. So our roots are x is equal to negative 1 and 5. So notice really all that happened, and we've talked about this before, okay, is my roots are the opposites of the signs of the factors. So we've talked about this before, that when I want to find roots, x-intercepts, that kind of stuff from factored form with quadratics, we have to take the opposite because they're inside the parentheses. Well, this is really the math behind this. This is why we take the opposite, because we'd have to set it equal to 0 and then solve out for that value. Okay, but those are solutions, those are our roots, that's what we're looking for. So essentially our steps here is to factor it like normal, and then set our factors equal to 0 and solve them for the x values. So we're really just adding that one extra step of setting equal to 0 and solving. So let's look at another one. So factor the polynomial y is equal to x squared minus 8x plus 12. Well, as usual, we look for a GCF, 1, negative 8, and 12. 1 is there, so nothing can be taken out as a GCF bigger than 1. Everything doesn't have an x, so no x to worry about. So then it's a times c, so 1 times positive 12. And then, of course, my b is negative 8. Now, this one's a little different. I still have a positive 12, which means my factors have to have the same sign, but I'm adding up to a negative 8. The only way for something to multiply to a positive and add to a negative is if they are both negative factors. So for 12, for my factors, I'm going to list all the negative factors instead of the positive factors. So negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. And then, of course, we add those together. So negative 1 plus negative 12 is negative 13. No good. Negative 2 plus negative 6 is negative 8, which is good. So that's the one we want. We stick everything on the outside. X minus 2, x minus 6, x times x is x squared, x times negative 2 is negative 2x, x times negative 6 is negative 6x, negative 2 times negative 6 is positive 12. X squared is x squared, negative 2 plus negative 6 is negative 8x, 12 is 12. So we are good. Our factored form is y is equal to x minus 2, x minus 6. All right, so let's move on to what we're actually working on in today's notes, which is solving. So we want to find the zeros. Remember, zeros are the same as roots, solutions, x-intercepts. So we're doing the same thing we did in number 1. We already factored this. We got y is equal to x minus 2, x minus 6, which means I can set these equal to 0, x minus 2 and x minus 6. And then once I set the whole equation equal to 0, I can set the separated factors equal to 0. And remember, this is still equivalent to writing it the other way. So if this makes you feel a little bit better solving for x, then of course do this to make yourself feel a little bit better. But with both of these, plus 2, we get x is equal to 2. Plus 6, and we get x is equal to 6. So for our final answer on number 2, my zeros are 2 and 6. All right, pretty easy, pretty smooth sailing. Okay, we're really just adding that one step of once we factored it, set the factors equal to 0. Okay, and that is your final answer. Pretty straightforward with what we're doing today. Let's look at one like number 3. G of x is equal to x squared minus 11x. So one thing you might notice right off the bat, this is and isn't in standard form. Okay, we have ax squared plus bx, but then our c term is missing, which really just means c is 0. So we're really not going to do 1 times 0 because that's just 0 and there's no factors with 0. So instead, let's look if we can maybe take out any GCF. So 1 and negative 11, so I can't take a number out, but x squared and x, I can take an x out. So if I take an x out as my GCF, that would leave me with x and negative 11. Okay, now if you notice, okay, I have x and x, which is the same thing I always have when I factor. I just have single x's separated out like this. So I've factored this function already. Okay, so sometimes just taking a GCF is all you need to do to factor the function. So we can go ahead and move right on over to finding the solutions of x squared minus 11x, which, like we said, is already x times x minus 11. We already did that factoring for us. Okay, so here it's already set to 0, so that's easy. So now I'm just solving for those x values. So x is equal to 0, and x is equal to, or sorry, x minus 11 is equal to 0. Now the good news, x is equal to 0, that one's already done. I don't need to move anything, x is already by itself. X minus 11, I do still need to add 11, which gives us x is equal to 11. So my two x values, my solutions, are x is equal to 0 and 11. So even though it's weird, actually was way less work than all the rest of them. So sometimes the weird ones can be nice. Okay, let's look at number 4. This is an a is greater than 1. We might be able to take a GCF out. So we do always want to check for that. But a greater than 1, so it's going to be a little harder to factor. So let's check. So we have 3, we have 22, and we have 7. Well, 3 is only divisible by 3. 7 is only divisible by 7. So that's no good. And 22 is divisible by 2 and 11. And then, of course, 22 and 1. So nope, nothing really works together. So we cannot take a GCF out here. So we're just going to move on. So our first step is a times c, which would be 3 times 7. Which is, of course, equal to 21. So we want factors of 21 that add up to our b, which is negative 22. So once again, our b is negative, our ac is positive. So we want negative factors because negatives multiply to make a positive, but add to stay negative. So factors of 21, we, of course, have negative 1 and negative 21. Negative 3 and negative 7. And that's really it. 21 doesn't have a lot of factors. Okay, negative 1 and negative 21 does make negative 22. So we are good to go on the first one. Okay, so ax squared term goes in the top, so 3x squared. C term goes in the bottom, so 7. And then my factors go in the diagonal, so negative 1x and negative 21x. And then I factor out across rows and columns. So 3x squared, negative 21x. I can take 3 and x out. Okay, 3x squared and negative 1x. I can only take x out. Negative 21x and 7. I can take 7 out. And negative 1x and 7. I can take out just 1. Okay, now you might be noticing a problem here right now with what I factored out. I have x, I have 3x, I have 7, and I have 1. 1 times 7 does make 7, but 3x times 7 doesn't make negative 21x, and x times 1 doesn't make negative 1x. Well, I can still take a negative out of both of these, okay, as a GCF if I wanted to. Okay, you can take a positive or a negative out, whether they're both negative, they're both positive, that's still legit. But I need to make them both negative because I want my negative factors to multiply to 7, but add up to negative 22. So that's why we still make them both negative. So from here, our factored form is y is equal to x minus 7 and 3x minus 1. Okay, so we're good to go. Okay, let's go over to our solving step. So solve 3x minus 22x equals negative 7. Ooh, that's weird. That's not the function we started with. So sometimes you're going to get these solving ones that aren't already ready to go. They're not already with all of our terms over on the left side. So if you ever get something like that, notice we still have our ax squared, our bx, and our c. C is just stuck over on the other side of the equal sign. So what we can do is we can just use our solving steps to move that negative 7 to the other side. Okay, and I know it looks like I'm adding it to 22x, but 7 and 22x are not the same kind of term, so I'm not going to add it together. So it's going to cancel out over on the left and give us 3x squared minus 22x plus 7 is equal to not nothing. We would still write 0 because negative 7 plus 7 is 0, but because we want to have something over on the right side of the equal sign, we got to fill it in with a 0. Okay. Now from here, this looks like we factored, so we can go ahead and go straight to our factored form of x minus 7 and 3x minus 1. And then now we can set both of those factors equal to 0. So x minus 7 is equal to 0, and 3x minus 1 is equal to 0. Okay, from here, add 7, we get x is equal to positive 7. From here, add 1 and add 1. We get 3x is equal to 1. And then, ooh, because x has a friend in front of it, we do still have to divide that number multiplied away. So we do get as a final answer that x is equal to 1/3. Okay, so a little extra step. Anytime you have an a is greater than 1, so you're going to get one of your factors is going to have a number in front of x, you are going to usually end up with fractional solutions or values of x. So from here, our final answer, x is equal to 1/3 and 7. And that's it for solving all. I mean, they do get a little, trickier like number 4, but some of them are, of course, still nice and easy, like 3, 2, and 1. But that is it for solving. You just take what you've already factored, set it equal to 0, and solve both of those as if they're their own separate equations. And pretty simple, 1 to at most 2-step equations to solve for, y'all. So that is it.